just so if you get to this point later and you're looking and go, oh, I wish I'd listened, you'll have it. Okay, so 9 says write it as a trinomial. What that means basically, I tell you what, anytime you see these things stuck together like this, you're basically going to do one of two things. You're either going to multiply it out or you're going to try to solve it by setting it equal to 0. And they told us to write it as a trinomial, so we're going to multiply it out to do that. So you're just going to do the basic distributing. 3a times 4a is 12a squared. 3a times negative 1 is negative 3a, right? And then I got to go distribute the negative 2 here. Negative 2 times 4a is negative 8a, right? And negative 2 times negative 1 is positive 2. And the reason it becomes a trinomial, tri means 3 terms, because don't these middle terms combine? And so I go from having 4 terms to 3 terms. I'll have the 12a squared still. Come on, get down. There we go. 12a squared. Negative 3a minus 8a, remember, would be negative 11a. We add the numbers out front and then just stick the variable on there. And then plus 2. And so that's 3 terms right there. That's why they call that a trinomial. I tried to use the exact wording that was on the test just so you'd also get used to that wording, because sometimes that's half the battle there, is just knowing what they're asking you to do. Okay, so for number 4, I bet on the test this will be one of the most frequently missed problems. And the reason is when you go to square 5b on the bottom, you got to square both parts of it. You got to say, that's the same thing as saying 5 squared and b squared if you were to write it all out. And it's easy to think it's just 5b squared. But you got to square each part of that term. So 5 squared ends up being 25 on the bottom, and then you got the b squared. Now aren't you b?
I don't have to roll that because I already know that.
Good. Okay, we could go over 3 too. So the b squareds here would cancel out, and then I've got 5 over 25. But doesn't that reduce? 5 goes into 5 one time, 5 goes into 25 5 times. So number 3 is another one. Y'all want to go over number 3 too? 3 also? I'll say 3 also instead of 3 too. Okay, so number 3, the problem was negative 25 a cubed b, oops, come on, show up, a cubed b over 15 a b to the 4th. So there's a lot of rules here we got to remember. I take these apart and I do one little thing at a time. For instance, the very first thing I'm going to do is look at the numbers. It's good. A negative divided by a positive, if you want to look at it that way, is a negative. So my answer is going to be negative. So let me just go ahead and put the negative out front. Come on, show up. Okay. Now I'm going to reduce 25 over 15. 5 divides into both of those, right? So how many times does 5 go into 25? 5 times. And 5 goes into 15? 3, right? So far all I've done is the number part. I'm going to color code this. I'm going to do the A's next, and I'm going to circle them in blue just so you can see where I'm looking. When I have a cubed divided by a, do y'all remember that it was often helpful to put a little 1 in there as the exponent just to remind myself that that means a to the first power? Because what's the rule when fractions are dividing? When you divide with a fraction, what do you do with the exponents? You don't divide them. When you've got this a cubed over a, you don't divide the exponents when you're dividing. What do? You subtract, right? So what's 3 minus 1 going to be? 2. And I put the answer on the side of the fraction bar that had more to start with, right?
To make it so I don't forget to subtract, I usually think of it as how many times does a go into a cubed, because if I always think subtraction,
then you kind of get stuck that way, or
yeah,
a lot of people do. What he's saying is you can write it out like this, or at least you could think this way. I think this is what he's saying. If you put 3 a's over a, you'd see that one set would cancel out, and you'd be left with a squared, wouldn't you? And they're on the top. So I could write them on the top. I could just say 3, subtract the exponents. 3 minus 1 is 2. That's the exponent on the A. And I had more on the top, so I put the A's on the top. If I use that line of thinking, what am I going to do with the B's here? What could I do to help? Couldn't I put a 1 on that B on the top? And I subtract the exponents. 4 minus 1 is 3, so it's going to be B to the 3rd power. But where am I going to put that? Am I going to put it on the bottom? Why?
Because the bigger one is on the bottom.
Right, there were more of them on the bottom to start with. I could also have broken it out like this and said that's B over B times B times B times B, because B to the 4th just means 4 copies of B. And then you could have, knocked out that 1 and seen that there were 3 left. But that would be your answer right there, okay? Hey, you're probably going to factor this, and probably you're going to need to keep breaking it down. So when you say completely, a lot of times they're kind of hinting to you that something else is going to happen. Now, I meant to talk to y'all at the beginning. If I've got 2 terms, and that's what I have here, I should first check for a GCF. Is there a GCF here? No. Okay, so after the GCF, if I've got 2 terms, I should probably think this is going to be a difference of 2 squares. But it's not going to be a difference of 2 squares if it doesn't have a subtraction sign in the middle. Does it have a subtraction sign up there between the 2 terms? Yeah. So this is a difference of 2 squares. So you could think this way. What do you square to get x to the 4th? X squared. Let me go ahead and write it in there in a different color. And what do you square to get 16? 4. So if I factor this, I'm going to take that x squared and put it here and here. And I'm going to take the 4 and I'm going to put it here and here. And I need 1 plus and 1 subtraction, right? Now, is that factored completely?
No. Oh, I missed it.
Which one could you keep working on? Can you break down x squared plus 4? Is that a difference of squares? Why not? It's a plus, yeah. Pluses won't break down, so we can't do anything with them. We just have to carry them along, and we're going to learn about how to do that probably next year, maybe this year, we'll see. Now, x squared minus 4, is that a difference of 2 squares? It is. Couldn't I say that is x squared minus 2 squared, right? That's 2 squares there. So that one will break down. I'll do it in red just so you can see where everything's coming from. X minus 2 and x plus 2. You put the x in the first 2 spots, the 2 in the last spots, and then you need 1 minus and 1 plus. Doesn't matter which one you write first. Is it completely broken down now? The x minus 2 and the x plus 2, they are, because you can't break down something that's got just an x in it anymore. The x squared plus 4, we already said we couldn't break it down, so we are finally finished here. Could I solve this by setting it equal to 0?
Oh.
That's why we do this, is so we can solve it, if you remember. But they didn't tell me to solve it, they just told me to factor it, so I factor it. And that's all I would do here, okay? I have a feeling that's good. Like this, on the test, they're going to give you something a lot like this that's multiple choice, and they're not going to factor it all the way down, which is why I stopped where I did. Sometimes I don't remember why I did what I did when I make these reviews. But on the test, for this one, they gave you 4 choices, and they circled the answer that looked like that. Okay, so even though it would break down further, they didn't go all the way down with it. So you need to recognize that if you see that happen on a multiple choice thing, you could stop here and write it that way. That's really not the preferred way to do it. This would be the preferred answer, but that's not one they gave on the test. Don't know why they didn't, but they didn't. Doesn't make sense to me why they wouldn't have.
Oh, no, you're right.
All right, it's time.